Hello and welcome to another maths video. Today we're going to look at solving simultaneous equations using elimination. So didn't look at the last video, go back and watch that. We talk about simultaneous equations, what they are, what we're trying to do, and elimination will form our second method. The last method we did was substitution, and substitution is probably a more general method, more effective, always works. Elimination can be a little bit trickier. Though I do find some students actually prefer the method of elimination, so whatever works for you, knock your socks off. But the question in an exam might ask you for a particular method, so bear that in mind. So you do need to know both methods when it does come to solving simultaneous equations. Anyway, without further ado, the method of elimination. So starting off with two simultaneous equations, let's say that x plus 4y equals, oh dear, x plus 4y is going to equal, let's say, 9. And we'll say that minus x plus 3y is going to be 5. Okay, and you can probably guess what the solution is in your head. Yeah. Elimination. What the whole idea of the method is to do, it is to eliminate one of our equations, one of our prime numerals, by adding or subtracting the equations. So I've got equation 1 here and equation 2. I'm going to add or subtract them in a way such that one of my variables is eliminated. Okay, so I'm looking here to eliminate either the x's or eliminate the y's, and that all depends on the coefficients. So here, x there is of course 1x, the same thing. Minus 1 here is the same as minus 1x. I've got a coefficient here of 4, coefficient here of a 3. So what I'm going to do, I'm going to take equation 1 and 2 here. If I add them together, so equation 1 plus equation 2, what you'll see here is my x's will be eliminated. So minus x, or sorry, x and minus x. So if you do have, just on the side note here, like 1 plus minus 1, that's the same as 1 minus 1, which is 0. So the x's will go. So if I add them together, x minus x, 0. 0 x's. Then in terms of my y's, I have 4y plus 3y, so that's 7y. And then I've got 9 here plus 5, 14. Okay. So divide both sides by 2 gives me that divide both sides by 7. There you know the answer. Y is 2. Okay, so that's our first prime numeral there. Y is 2. Similar to the last time, we need to go through and find an x value as well. So I'm going to substitute that into equation 1. I would recommend using multiple colors for your questions here, just because it does get long and confusing as a marker. I mean, you can get a little bit caught up in text and stuff everywhere. Into equation 1 said that x plus 4y equals 9, so 4 times 2. We know that y is 2. Y is 2 from right here. Equals 9. So we get x plus 8 equals 9. So we get x equals, here's going to be 1. So my solution here, x is 1, y is 2. One, 2. Grab me a second example, because one's never enough. My second example here, I'll say, for question 2, we'll do 3x plus 2y, and we'll also go, let's go 5x plus 2y. And this can be equal to 8 and 14. Okay. And no, 12. Make it 12. Alright, so method of elimination, we're trying to eliminate one of our pronumerals, one of our variables. Looking for the matching coefficients. You should have spotted it here already that in front of my y, I have 2y, I have 2y, they're my matching coefficients. If they don't come matching, I'm going to do a bit of work to make them match. Right now they do match those, so I'm going to work that space very nicely. What am I going to do? Well, I've got 2y, I want to eliminate 2y, so I need to subtract. So if I do 2y minus 2y, I get 0y. Or 2y minus 2y, I get 0y. I'm going to do here equation 2 minus equation 1. If you do it the other way around, if you do 1 minus 2, that's fine as well. If you put a plus in the middle though, you're not going to get very far. If you put a plus in the middle, just so you know, you would get 8x plus 4y equals here 20. You haven't actually eliminated a variable there. You got your equation here with 2 unknowns. That's not very helpful. But if I subtract, then I will reduce it to 1 equation, 1 unknown. If you don't believe me, watch me do it. So 2 minus 1, like terms, 5x minus 3x is 2x. 2y minus 2y minus 2y is 0y. So they're going all together. Okay, so I can write in here literally plus 0y. Good as well. Then 12 minus 8. 12 minus 8 is 4. So I got 2x equals 4, x equals 2. Okay. I want to go through and find a y value now as well, so I'm going to substitute that back into an equation. It doesn't matter which one. I'm going to substitute it into equation 1. Something into equation 1 gets me 6 plus 2y equals 8. So I get 2y is 2, I get y is 1. Y is 1. So my solution then is 2, 1. Getting a bit more advanced. Wait for this loading to happen. A bit more advanced. So if I have 4x plus 3y, and I have 5x plus 2y, and the first one here I'm going to say is equal to 11. I'm going to say the second one down here is equal to 12. Okay, get your guess them in your head. You need to see some evidence of your method. Alright, so looking for matching coefficients. And hopefully it doesn't take you very long to realize that there are no matching coefficients here. 5x and 4x, they're different. 3y and 2y, they are different as well. So I need to multiply to get the coefficients to match. So I can either multiply to get the x's to match, or I can multiply to get the y's to match. Doesn't make a difference. Okay. If you're lucky, one of them will be just 1y, then I'll multiply this by 3. But here, no dice. We've got 3 and 2, or 4 and 5. I'm going to multiply it to get the y's the same. We'll keep my numbers probably a little bit smaller. So we're going to try and get 6y out the front. So we're going to take equation 1. I'm going to take equation 1. I'm going to multiply equation 1 by 2. That's going to get me 8x plus 6y equals 22. I'm also going to take equation 2 multiplied by 3. So equation 2 multiplied by 3, I'm going to get then 15x plus 6y equals 36. What I'm noticing here, 36, is that my y's match. Like I tried to fudge it so my y's would be the same. Here we go, my y's are the same. Just for labeling's sake, I'm going to call this equation 1a. People will call it equation 3. I like to use a. and equation 2a. What I'm going to do now, I'm going to subtract one equation from the other because I've got plus 6, I need to minus to get rid of the 6's. So I'm going to do equation, and again I'm going to do 2a minus 1a because the 15x here will cancel to keep it all positive. So 2a minus 1a, doing it by like terms, x is 15x minus 8x is 7x. 6y minus 6y is 0. And 36 minus 22 is 14. Okay, so here x equals 2. To go and get my y value, substitute that x is 2 back into one of my equations, doesn't matter which one. Just sub it into equation 1. Oops, sub into 1. Sub into 1. Alright, so 1 is 4x plus 3y equals 11. So 4x plus 3y equals 11. 4x is 2 plus 3y equals 11. If you haven't copied some of this down, I would recommend copying it down as I go. You can pause this video. So that gets you 8 plus 3y is 11. So 3y is 3. If you minus 8 from both sides, that cancels very nicely. So from here, y equals 1. So I have my solution here, x is 2, y is 1. Make it nice and clear. X equals, so my solution here, let it load. Is x equals 2, y equals 1. Okay. Get some practice. What we're trying to do is let things load. What we're trying to do is match the coefficients on our original equation. So here I sought to match the coefficients of the y's. Once I've got matching coefficients, if my signs match, if it's positive, positive, I'm going to subtract my equations. So you see here I subtract my equations to cancel them out. If you had 6y plus 6y, that would get you 12y. So what I'm going to do is 6y minus 6y, cancel that out, get rid of the y's. Okay, we're trying to get to one equation, one unknown. Talked about this a little bit already. One equation, one unknown, you can do. So we eliminate the y's. Method of elimination. 6y minus 6y, there you go. Or 6y minus 6y, there you go. Similarly, up the top here, going back to question 2. Man, the loading is killing me today. When the coefficients match already, here, positive, positive, I'm subtracting my equations. Okay, so again, 2y minus 2y will cancel. 5x minus 3x is 2x. Okay. In the case that my signs that I start with are different, so here I started with positive x and negative x, I add my equations because that will then cancel the x's. So minus 4 plus 4 is 0 already. Okay, or minus 3 plus 3 is 0. Or 3 plus minus 3, 3 plus minus 3, yeah, is 0 as well. Okay. Have a go at a few. Method of elimination, I find a bit trickier. Some students enjoy more. It is more of a university level for linear equations. Yeah, I mean, it's a method you are required to know it. We can ask you questions using it in particular. The nice thing about this method is you will avoid fractions. So in my video on elimination, sorry, my video on substitution, I talked about fractions. If you're substituting with fractions, things get nasty. This method here you don't really deal with fractions unless they kind of come in the question. So avoiding fractions, this method is great, even if it can be a little bit less useful in other scenarios. Thanks for watching. Enjoy doing some questions for yourself. Again, if you've got questions, let me know. Thanks.